So I think that covers the battery pretty well and about how you bring the power together. In the rules, we talk about having a kill switch and making sure that you can disconnect from the power. And then we also need to control, and the BMS is part of that, but also just operating the craft in general.
Right.
So what happens next?
Sure. So I was talking before about contactors, and so for those who are not as familiar, a contactor is essentially like a low voltage controlled switch that switches the high voltage, high current appliance. So in the case, you have the ability to have a little switch or a key or something with a thin gauge wire that's conveniently placed at the helm, and it goes back to this device that disconnects and connects the power to your controller and from your batteries, to disconnect them from each other if it's a bigger battery bank and things like that.
Sure.
The advantage of something like that is that you don't have to have your heavy gauge wire running all over the boat. So if you managed to get an actual switch that you were going to be using to disconnect and connect the power, then you would want to be able to have, let's say your battery was conveniently someplace else in the boat, you would have to have your lead run right up to your helm, wherever you were to be driving the boat from. For safety, you would want to have it like right at your fingertips, and then switched and then continue back to wherever your controller and your other parts are. And that might give you a longer run of the cabling, more resistance, less efficiency. You're better off having all of your cabling as direct and as short and as sort of precise as you can make it to minimize the extra resistance that you're getting through all your cabling.
Right.
And then so you have something like your contactor. So the beauty of something like a contactor for an emergency disconnect is you could have multiple ways to break that circuit. So you could have in series a key and also like a kill lanyard. And if either one of those is turned off and that circuit is broken, your motor will lose power.
Sure.
And so the beauty of that is with one circuit, you can have a key to disable it so somebody can't just hop in the boat and take off. But then if you were to fall out of the boat, you wouldn't have to, on your way out of falling, turn the key and kill the engine, by just pulling that lanyard. So that's a nice way to use basically something like a contactor can sort of solve that problem.
Right. And I think for the unmanned boats, we want to see that switch also, so that when we're operating even in the parking lot at PEP, that we can kill power as needed. And then the other thing that needs to be included is whatever transmitter receiver that you're using, the baseline code has to be looking for a contact every 0.02 seconds or so.
And
so that
not throttle up by itself, basically.
Right, and when that OK isn't received, that it goes down to no power.
Right.
Yeah.
So, and the other thing would be, it's ideal to have some kind of a light that shows that your system is hot, that it's activated. And that's also good from a troubleshooting standpoint. If you turn the system on and you don't get any throttle, then if you just glance down and your LED is not lit up, then you could say, oh yeah, I forgot in my BMS through my Bluetooth app, I disconnected the battery because we were transporting or whatever. But if you're not sure if it's problems with your controller or some other thing, it's helpful to have more ways to look at your system and understand where your problems may be arising. Most that I'm aware of, most RC type receivers use a pulse width modulated signal that they feed to the controller, and it's between like 1,000 and 2,000 pulses per second. And when you have it disconnected and there's no reception, it gives you no signal. So the beauty of that is that there is no default to spinning up the motor. You can't leave it in gear, and then when it disconnects, it continues spinning along at full speed.
Right.
It needs to continuously receive that position. That's the position equivalent pulse width modulated signal to continue running it at that speed. And so even if you're not using an RC controller, even if you're using some other system that is going to be controlling those same kinds of speed controllers, they're going to be expecting a pulse width modulated signal. So usually that's an easy thing to solve because the default is the way you'd want it to be. You have to be continuously generating a signal within a range to keep it going. And if something shuts off with your hardware and your controller's not receiving that signal, then it is easy to have it stop. But if you do have, I would say maybe if this isn't obvious, if you're going to have a boat that is going to be truly autonomous and you want to be able to sort of activate that autonomy, having it set up dually with the ability to flip a switch and manually take control is, I would say, pretty critical in that, because if it thinks it's doing what it should be doing and it's headed right for the children's swimming area, you know,
right.
yeah, certainly you want to be able to say, oh, let's stop it from going over there. And so being able to take over control is critical.
Well, yeah, so in the Navy, it's the man in the loop, right? That's what we look for. And I think some of the teams do get into a little bit of like working with like a Raspberry Pi or even like an ArduPilot type of code. And usually the Raspberry Pi comes involved where they need to power up the system in a certain sequence. And so that gives them that control where they can just hard code it. But again, like as we put any code into the boat, we just want to wrap it with some safety. So if it's not operating in a way that we know that everything's on target, that it shuts off.
Yeah. And I would say maybe from a approachability standpoint, something like ArduPilot, being that it's already a very well contributed, crowdsourced, feedback on what has worked for different people.
Right.
It's less to figure out the first time out of the gate. Whereas if you're sort of building your own Arduino or Raspberry Pi based system, and you have to make sure that every aspect of it is been fully, all the problems have been worked out of it, you have a lot more sort of maybe flexibility and configurability with a custom system. But I don't think you're necessarily going to feel overly limited with something like ArduPilot. I would say that's a good way to get started.
And I think it goes back to this theme too, right? Whether it's the batteries or the control system or the hull, but like having some kind of resource external that can support you, whether it's a community or the salesperson.
Right.
Those are going to be some of your best subject matter experts. So finding those kind of companies is worth the money, honestly.
Yeah, it's true. Yeah, because just getting the best price online doesn't necessarily make your process easier in figuring out how to make that thing integrate well with your system.
And so there's kind of like 3 budgets on the boat, I think, right? There's the weight budget, the dollar budget, and then the time budget of just like how much can we put into this boat. And so when you have already got past your Gantt charts at this point in your build probably, you might want to look back at them and be like, all right, well, we really need to stick to this or figure out ways to like reallocate the time by spending a little bit more money here and getting more time back here.